Hi, this is Mr. Hetherington. We're going to start our lesson for today, and we are dealing with long division. So let's just remember how long division worked way back when. So back in grade 4, we probably had something that looked like 6 divided by, we'll pick a fairly large number like 1,255. And when we started this way back when, we'd say, okay, 6 goes into 1. Well, it doesn't, so then we have to go to the first 2 digits. 6 goes into 12 twice, so we put a 2. And then we do 2 times 6 is 12, so we would write that down, 12. And then we'd subtract. And then we would get 0, and we'd bring this down, and we would get 5. How many times does 6 go into 5? So how many times does 6 go into 5? Well, that doesn't go at all, so we have to put a placeholder. We get 0, and then we have to bring down the 5. And then how many times does 6 right here go into 55? So that's going to be 10 would be too high, so it would have to be 9, which is 54. So we go 9, and then we do our 9 times 6 gives us 54. And then we subtract those, and we end up getting 1. So it ends up that we get, when we do 1,255 divided by 6, we get an answer of 209 plus a remainder of 1. So there are lots of ways you can write that. So we get our original question, which would be 1,255 divided by 6 is equal to the 209, finishing with a remainder 1. Or the way that I like it is you could go and just write out the original 1,255 is equal to 6 times the 209 plus 1. And if you check that on your calculator, it should work. I've decided to start with an actual example because I find sometimes it's easier to do an example first and then kind of go through the formal aspects so you can see it all printed out all in one go. So if we take a look, we are doing just like we did before. We are going to do this ugly polynomial here divided by x minus 2. So we set it up and we go x minus 2 divided by x cubed minus 5x squared minus x minus 10. And we start off with what would multiply with this to give me this. So I would have to do x squared times x to get x cubed. So let's write that. Notice how I write it above the x squared term below. So if we look, the x squared matches with the x squared here. And then I multiply that. So I do x squared times this entire thing here. So let's do that. And that will give me x cubed minus 2x squared. And the whole goal was to get these two the same, so when I subtract it, it's gone. So let's do that. And we end up having, that will be 0, and we'll get negative 3x squared. And then we go through, and then we have to bring this down, and I'll get minus x. And then I go through the whole process again. What multiplies with x to give me negative 3x squared? That's going to be negative 3x. I put it up top, negative 3x. And then I do that actual multiplication, this times this entire thing, and I'll end up getting negative 3x squared, and then I do this times this, which gave me this. And I have to do the negative 3x times the negative 2, which gives me plus 6x. And then I minus that. Again, the whole point to get those the same, so when I subtract, I get 0. I do the subtraction, and I end up getting negative 7x. I bring this down, minus 10. I finish it off. What multiplies with this x to give me this? It would be minus 7. I multiply that out, and I end up getting minus 7x, and that's going to be plus 14. And I subtract that. Again, the whole point. So this subtracts to give me 0, and I end up getting negative 24. And then we have our final therefore statement. So that would be my original x cubed minus 5x squared minus x minus 10 is equal to what I divided by times my result and then my remainder, minus 24. Now the back of the book shows it a little differently, and I'm going to show you that on the next page, but this is the way I like to write it out, and I'll accept both. So let's take a look at the next slide. So for this one, again, if we look, we are taking this polynomial and dividing it by x plus 9, so we set it up here. I've written out all the steps here if you need it, but I think it was easier to do an example first. If we look for what multiplies with x to give me x cubed, and that gave me x squared. I take the x squared, I multiply it by this entire thing here, and I get this answer, and then I subtract, and the result ends up being 13. So I get x cubed minus x cubed, which is 0. 13x squared minus 9x squared gives me 4x squared. And I go through the process again. What multiplies with x to give me 4x squared? That would just be 4x. I multiply this with this entire thing, x plus 9, and I get this. And I subtract. And then I go through and do the subtraction. I get a 3x right here. What multiplies with this x to give me 3x? Well, that's just 3. I multiply this 3 with x plus 9. I get 3x squared plus 27. And then I go and I subtract. And I end up getting 19. Now, like I said before, this is how I like to write my final answer right here. But there is another option. You do have the option of the original question, which would be x cubed plus 13x squared plus 39x plus 46 divided by x plus 9. You get your end result plus, and then the remainder divided by what you started with. I don't like this one as well, but the reason it works is if I were to multiply both sides by x plus 9, and this one by x plus 9. Those would divide out. This would multiply in with this. That's where this gets picked up. And then this would multiply in with this, and the x plus 9s would divide out. So you can see that that would give me this as my end result. Memorize both. This is how I think it shows it in the back of the textbook. But again, I would accept this on a test as well. Okay, so hopefully the next ones go a little quicker. So again, set it up. X. I guess it's y, actually. Y plus 3 divided by 2y cubed plus y squared minus 27. Y minus 36. We're going to run through this fairly quickly. So What times y gives me 2y cubed? I end up getting 2y squared. Multiply that out, 2y cubed plus 6y squared. Subtract. When I subtract that, I get negative 5y squared. Bring this down. What multiplies with y to give me negative 5y squared? That's going to be minus 5y. And I end up getting minus 5y squared minus 15y. So what did I do to get that again? I took this number times the y plus 3, and I end up getting this. Subtract. When I do that, I will get the 0 there, and then negative 27 minus negative 15. That will be negative 12y. Bring down the negative 36. And what multiplies with y to give me negative 12y? That gives me minus 12. And I end up getting minus 12y minus 36. And of course, we get a remainder of 0. So that means it divides evenly. So my therefore statement, my original question, 2y cubed plus y squared minus 27y minus 36 equals those two polynomials multiplied together. Moving on. We're doing this question because it has a little weird setup. So if we look, y plus 4 divided by y cubed plus 0y squared. We have to put that placeholder in there because there wasn't a y squared, minus 28y minus 41. And then the process is the exact same. So I'm looking for something that multiplies with y to give me y cubed, and that would be y squared. Subtract. End up getting negative 4y squared. Bring this down. Hopefully you're kind of working or thinking ahead of me now. What multiplies with y to give me negative 4y squared? And I end up getting negative 4y. And I end up multiplying that out like I've done before. There's a squared on here. And I end up getting negative 28 minus negative 16. That'll be negative 12y. Bring this down. Number that multiplies would be negative 12. Multiply that, negative 12y minus 48. Subtract that, and I get 7. Write your final therefore statement, my original. Equals what I was dividing by times the result and plus 7 because the remainder was positive 7. So we're doing another one, again a little different because now I have a 2 sitting on this one right here. So let's take a look at how that one would work. We'd get 2x plus 1 divided by 2x cubed minus 3x squared minus 8x minus 3. Now that we're looking for one number that multiplies with the 2x to give me 2x cubed, that's x squared. Multiply that, 2x cubed plus x squared. We minus that, and we get negative 4x squared. We look for a number that multiplies with the 2x to give me negative 4x. That would be negative 2x. Multiply that, negative 4x squared. Forgot to bring down this one. And then when I do that multiplication, finishing it off, minus 2x. And then I'm going to subtract that. And I end up getting negative 6x. I bring that down, minus 3. A number that multiplies with 2x to give me negative 6x. That's negative 3. Finish this off, minus 6x minus 3. And if you can see, it works out perfectly. And we write out our answer. So 2x cubed minus 3x squared minus 8x minus 3 is equal to 2x plus 1 times x squared minus 2x minus 3. Now, if you can see where we're going with this, eventually, and we're not worrying about this today, but we've been able to factor a cubic now because there was no remainder. So if you look, I could go and finish this off in a future lesson, factor this one more time, and I factored a cubic fully. But that's for another day. Skipping this one. Okay, our last one. So if we take a look, set this up. Again, we're doing this one because there's another special thing we have to deal with. So if we take a look, what multiplies with the y right here to give me y cubed, and that's y squared. And then multiply that, y squared plus 4y. I forgot the squared on this one. And then that would be a squared here. And I minus it, and I get 0. So we wanted to give you a heads up on this special one. So I can't just bring down one of them. I have to bring down both of them, and I end up getting minus 3y minus 12. And I end up getting what multiplies with y to give me negative 3y. And that's pretty easy, minus 3. I put it over top of the constant term. Since there was no y, I left that blank just to keep everything organized. Multiply that out, minus 3y minus 12. Oh, if we look, we got another perfect no remainder, and we write our answer out. And that was our last question. If we look at the next slide, you'll see all the answers are on one page. So I skipped one if you were wanting to try it. The only thing is it's hard in math type to do all those little subtracts. So all of these little subtracts that were missed need to be in there. But otherwise, this is a complete set in case I ever made an error, which is quite possible. You've seen me teach. And you can see your homework sitting right at the bottom, so right here. So hopefully this all made sense. If we had any issues, we can clean these up after the test, which is, we have the test on Monday, and then we can clean any of this up on Tuesday. Have a great weekend, and we'll see you on Monday.